Okay, let's review some weather information. How do we get information about weather, basically, and the questions that will be related to that on the FAA exam. Okay, so start out knowing that there's forecasts and there's observations, of course. Observations are that raw weather data that we get from a METAR, or they come from many different sources. Could be from weather radar, satellites, a pro flyer, in other words, professional airline pilots, etc. Um, so all this information gets sent to a central location where technicians uh, analyze it. Also goes through computer programs as well that can sort of sort through all the information. Just think about that, just absolute thousands and thousands of pieces of information that are fed into the whole weather forecast reporting system that to be interpreted. So very complicated process, but um, they're provided for us for not only for us, but also for ground transport, ocean-going transport. Weather information is disseminated really freely throughout the world. It's an amazing system. Um, Forecasts are basically predictions of the development or movement of weather phenomena based on all of these observations that are made. Right? So the primary way of distributing weather reports is through a METAR system, aviation routine weather reports. The code that we need to be familiar with so we can interpret it on the test. Uh, could be from many different sources. It doesn't really matter, but we get the code and then we are asked to interpret. Okay, we have weather observations are based on units like this AWOS system here that you see a picture of. Electronic data collection centers that on many airports throughout the country. The important part for you is to realize that ASOS is supported by the FAA. The FAA administers it, monitors it, collects that data. So it's basically for aviation, aviation operations, and aviation weather forecast. What ASOS is for. Now we have AWOS. We have AWOS, which is a automated weather observation systems that's administered by NOAA. So there may be questions about that. But anyway, both systems really provide continuous minute-by-minute observations and basic observing functions necessary to generate the METARs. So they're both sort of go into a big pot and then they're shaped up. No, it's sent actually through computer programs and a centralized location where the briefers are not only briefers, but analysts, technicians are analyzing all of this information to give us forecasts. Of course, reports are important for every individual airport, and they're transmitted, as we've talked about before. We get that either through a telephone or telephone briefing with a flight service station or on the radio frequency. Right. Now, next slide. So here's what a sample question here. Which statement is true concerning ASOS, AWOS weather reporting systems, right? Each AWOS station is part of a nationwide network of weather reporting stations. That's true. ASOS location, but is that the best answer? We have to keep reading. ASOS location perform weather observing function necessary to generate METARs. Yeah, that's pretty correct. Both ASOS and AWOS have the capability of reporting density altitude. Okay. NOAA does not need to generate density altitude because that's very specific to airplanes. Okay, so that's a clue. And also C refers to an airport, so AWOS is not specifically for airports. So B is the correct answer in this case. Okay, here's the big picture of this, or already been familiar with it. We've been going through this before, but this is the code, how you interpret the code, right? Type of report, METAR, station identifier, date and time. Since it's a report, it's just going to give the actual day of the month, not the month or the year, obviously. 1955, that's Greenwich Mean Time or Zulu time. Automated, and the wind is this one over here, 180 variable to 250, just telling the wind's shifting back and forth. Visibility, runway visual range, not something we need to be concerned about. That's for a specific runway, using the runway. The present weather saying plus heavy thunderstorms and rain shower, mist, sky condition, overcast at 100 feet with cumulonimbus, temperature 18 and dew point 16. Humidity 2992, remarks the specific kind of ASOS machine that's observing this. Thunderstorm began at 2.5, thunderstorm overhead, moving east, But anyway, so each one's going to be different. We just have to be able to use this code. It's not that difficult. Okay, here's a METAR report. This is this appendix 2, figure 12. These are the only METAR reports you'll need to interpret on the FAA written test. So it makes it pretty simple. It'd be a good idea for you to go through it and say, understand everything that's being said in all of these lines. It's pretty simple. This is actually the easy part of the test, in my opinion. So, okay, so we look for JFK. That's one down here. JFK on the 12th of the month, 1853. The report says 180 at 4 knots. Okay, so now all we got to do is figure out the answers. Let's see. Okay, C is wrong. Can't be that. 180 true or 180 magnetic. Okay, so what if it's a written report? It's going to be true. A would be the correct answer, right? If it's spoken or on the radios told you, it's going to be magnetic because it refers to your position. But this is something you read a report. Be true. Wind direction is going to be true. Here's another METAR report, figure 12, what's the current conditions for Chicago Midway? So Chicago Midway, that's right here. 180 or 12 on the 12th, 1856, 320 degrees at 5 knots. Oh, I guess we need to look at the answers. They're not asking about wind, but there's the visibility 1 and 1/2 SM. Okay, so this says 2 miles, so that eliminates that one. This one says 1 and 1/2. Okay, so it's got to be one of these. Is it rain or heavy rain? You just pick through it and see. RA just says RA, rain. No plus sign. Just to verify, we look at this. Overcast at 007, so that's 700 feet, not 7,000. So that's wrong. This has got to be the right answer. A, 700 feet, visibility 2.5 with RA, rain. Half. These are pretty simple. Another one, remarks for MDW. W is here. Down here, remarks would be RMK. It says RA, which should give us a clue. Rain is RA. B, 35, again. Okay. So it says blowing mist. What? It doesn't say anything about visibility. So that's correct. 1.5 mile visibility. But doesn't say anything blowing snow. See where they got that. Rain began at 35. Ooh, that looks familiar. Barometer has risen 0.35. No, that's having to do with the barometer. So it's got to be the rain began. These in mind as we go through. We have different kinds of weather charts. Surface prog is a report as well. It's just telling you what the weather is like now. Radar summary is telling you what kind of precipitation or radar returns, basically, right now. So they're reports. Satellite imaging is taking a picture of what's happening right now, so they're reports. But we have forecast. Now, forecast is another thing. We have several different kinds. We have terminal area forecast, or a TAF, and then we have area forecasts, which are listed as FA. So they just reverse the letters. Terminal area forecasts are located. You can find them at aviationweather.gov, or you can call 1-800-weatherbrief.com, or call the phone number rather, or check the website, same letters. You get these forecasts. Come in these regions. That's okay. Different kinds of terminal area forecasts. Okay, terminal area forecasts are for specific airports. Terminal, that's what terminal means. It's at the airport. So the weather within 5 miles of the airport are forecast for that area. So you're 20 miles away from the airport. It's maybe very similar, probably going to be similar, but it may not be exactly the same. So that's important to remember. Terminal area forecasts are for a particular terminal. You have 3 different kinds. Got TA, just plain old TAFs, got terminal forecasts that are amended, and terminal area forecasts that are corrected. That's all that means. Don't need to worry about it too much. Other kinds of forecasts are AirMets. AirMets are intended for pilots of light aircraft, single engine aircraft, drones, of course. But there may be stuff that a larger airplane might be concerned about, right? They would cover things that may be hazardous, such as moderate turbulence, icing, low visibility. They're just less severe items, and they're issued every 6 hours. About all you really need to know about that. We have SIGMETs. That's what you need to compare the two. SIGMETs are for really serious stuff. Okay, for all pilots, drone pilots, the largest aircraft out there, pilots. They're to alert pilots to potentially hazardous weather conditions that would definitely affect the safety of an aircraft. Things like severe icing, severe or extreme turbulence, widespread dust storms or sandstorms, volcanic ash, hurricanes. Yeah, SIGMETs are valid for 4 hours, but can be valid for 6 hours in some cases. SIGMETs, yeah. Other kinds of SIGMETs, specific kinds of SIGMETs, are convective SIGMETs. Convective SIGMETs, that's another weather advisory for a hazard. So specific hazardous weather situation. So convective, right? That's like thunderstorms, basically. Valid for 2 hours. Severe thunderstorms with surface winds greater than 50 knots. So there's some specific things here. Winds greater than 50 knots, hail greater or equal to 3/4 of an inch in diameter, tornadoes, embedded or thunderstorms or lines of thunderstorms, those kind of things. So way more serious. So here's the questions. What would the convective SIGMET be issued for? Obviously, ball line thunderstorms. Visibly less than 3 miles. Now that's an AirMet. Surface winds greater than 40 knots. I said surface winds 50 knots or greater. That's wrong. Got to be A. Question. Sometimes we can get the weather from this is of course back to METARs, but we get the METAR through ASOS frequency here. Okay. Or like I said before, we can access these reports or forecasts through flight service stations, telephone number, or go to the internet portal, or you can go to aviationweather.com. Either source, but you are responsible for getting the weather. Drone pilots are responsible for the flight to check local environmental factors. Phone call, we have 3 different kinds of briefs. Then you will be tested on that as well. We've got a standard brief, which is what you get just before you fly. It's about all the information that you could possibly get. An abbreviated brief would be if you were delayed after the standard brief and you were let's say we were supposed to leave at 10 o'clock in the morning and you don't get around to leave until noon, you might want to call just before and get an abbreviated. Say, you got to tell the briefer if you call them, I've already got the standard brief, so I don't need all the information. I just need whatever has changed since the last time I talked. Or an outlook brief would be going to fly on Tuesday, Monday Monday evening, you'd call and find out what's going to be like tomorrow. Okay, so this is a question. To get a complete weather overview for the planned flight, the remote pilot command should obtain what kind of briefing? Choices are Outlook, abbreviated, or standard. Would be a standard briefing, right? To complete weather overview. Complete would be a standard briefing. Following considerations is most relevant to a remote PIC when evaluating unmanned aircraft performance. Current weather conditions. That's extremely important. Performance has nothing to do with the number of crew you have, or not, somewhat related to the type of operation, but not as important as current weather. Remember, the current weather includes density altitude numbers as well. Okay, so that's the website you could go to, flightservice.com. Just to remind you again that VFR 107.49 pre-flight inspections and actions assess the operating environment considering risks to persons or property. Assessment must include local weather conditions. Part of the flight service station briefing includes airspace and flight restrictions, by the way. Okay, we have many different kinds of weather data, sources of weather data. There's another one is Aviation Weather Center. So either one of those. The benefit of flight service or 1-800-weather.com is that they keep a record. You log in with your name, and there's a record of it. Aviation Weather Center, you just get the information, and then there's no record of it, which is okay. But okay, you better know this. All right, standard temperature and pressure values for sea level, 15C and 29.92 inches of mercury. So don't let the 59 degrees, because this 59 degrees Fahrenheit, that is correct. However, 29.92 millibars, that's not correct. A is the correct answer. Okay. Another question, clouds, fog, do always form when water vapor condenses. Water vapor is present? No, it's always present, almost always. Relative humidity reaches 100%. That's close, but not quite. Sometimes you can have 100% and not have condensation. Based upon your pre-flight evaluation of weather, the forecast you referenced state there is unstable air mass approaching your location, which would not be a concern. Okay, so again, we have a not. Okay, so unstable air. Okay, so unstable air, you'd expect thunderstorms. You'd expect turbulent. You wouldn't expect that or stratiform clouds. So the not makes it not stratiform clouds. You wouldn't expect that. Unstable air mass is most likely to have which characteristics? No, I'm sorry, stable air has which characteristics? Would be the poor surface visibility, generally speaking. Showering precipitation, turbulent air, more likely unstable. Poor surface visibility would be the correct answer for that one. Figure 23. Why would you look at figure 23 for this question? What are the VFR minimum visibility requirements over this airport? It's always 3 miles. So don't let these spend a lot of time trying to second guess yourself at this. They're the same. You don't need to take the time to look it up. 78. What's the minimum base of the cloud layer to fly to the top of the towers 4 miles east of Onawa? So there's Onawa. 4 miles east. You just have to sort of guess. This is east, of course, so there's probably this number here. Right, so let's see. What are the answers here? The answers are, so is the minimum base cloud layer to fly to the top? Okay, it's the top. So cloud layers, you could take 292 and add 500 feet to that. 792. So that one looks right. Is it? Yep, it says AGL. So that 1335. If you had 500 of that, you don't get anything really that's close to this. So that's just MSO. That's the top of the tower. You still fly 500 feet above it. Okay, so wait a minute. Let me think here. Let's see. Make sure we read the question right. What is the minimum base of the cloud layer to fly to the top of the towers? Oh, wait a minute. That's how high you can fly. Yeah, right. You can fly to 492 feet. You'd still be 500 feet below the clouds. Okay, characteristics: moist, unstable air. Unstable air, you can have no unstable air. You're going to have precipitation and turbulence. I would say this is the correct answer, and it is. Poor visibility and smooth air, that's stable air. Haze and smoke, stable air. So and there's no not in there. What causes variation in altitude setting between weather reporting systems? Uh, Unequal heating, the Earth's surface. Coriolis has nothing to do with the direction of the winds, yes. Variation in terrain elevation, it's all corrected for that. Wind shear can exist at all altitudes. Best flying conditions, cool air, dry air, yeah. Forecast. Okay. Stop right there.